We all know that iconic image, right? Buzz Aldrin saluting the American flag on the moon. But what if I told you that the dust there, or should I say the lack of it, has scientists kind of baffled? Yeah, it's a real head-scratcher. Today we're diving deep into lunar dust, what it means for how old the moon is. And get this, maybe even the age of the whole solar system. We've got research papers, notes, even a pretty fiery opinion piece to dig into, a real mix. You know, it's one of those things seems simple on the surface, but then, whoa, it leads to some really wild questions. Wild how? We're not talking about like a little sprinkle of missing dust, we're talking potentially thousands of meters gone. Poof! Thousands! Okay, now I'm all ears. So help me out here. What made scientists think there'd be mountains of moon dust in the first place? It all goes back to the age of the moon. If it really is billions of years old, like most scientists think, well, it would have been hit by all this stuff, micrometeora, right? Space debris for billions of years. Makes sense. All those impacts, they grind down rocks, make dust, it builds up over time. So did the Apollo missions land in a lunar dust bowl? Then what did they find? No, not even close. The Apollo astronauts found just a few centimeters of loose dust on the surface. Really? Yeah, way less than what a lot of scientists expected. Some were even saying meters or dozens of meters. Wait, hold on. Didn't the Apollo missions measure how much dust was building up on the moon? I vaguely remember something about that. You're right, they did the dust detector experiment. They called it DDE. This Australian physicist, Brian J. O'Brien, designed it, flew on 4 different Apollo missions. Wow, yeah, and it collected data for a full 10 years, imagine that. Straight up measuring how much dust was landing on the moon. So what did it tell us? Was it just slower than they thought, the dust buildup? Well, the DDE, it found that about 1 millimeter of dust built up every 1,000 years might not seem like a lot, right? But here's the kicker. Over the supposed 3.5 billion years the moon's been around, that little bit of dust should add up to about 3,500 meters. Like picture 11 Empire State Buildings stacked on top of each other. Whoa, okay, that's a lot of dust. So we have this DDE measurement, what the Apollo astronauts saw, and then what should be there based on how old we think the moon is. Huge difference. What are the main theories to explain this missing dust? Did anyone try to just ignore it? Oh no, definitely not. Scientists have come up with a bunch of explanations. One of the big ones is those micrometeorites we were talking about. The idea is they hit the moon's surface all the time, stir things up, mix the dust into the regolith. Regolith? Yeah, the top layer of the moon's soil. Okay, so it's like mixing it in, but wait, can that explain 3,500 meters missing? Not talking about like mixing flour into a cake here, this is kilometers of dust, that's the problem. For that theory to work, you'd need crazy compaction happening in the regolith. Like squeezing 3,500 meters of dust into those few meters of regolith we see. You'd need to compact it 875 times. That's way more than anything we see in nature, geologically speaking. So micrometeorites, they're doing something but can't be the whole story. What else have scientists come up with? Another idea is that way back when, early in the moon's life, there were these intense periods of bombardment, asteroids, comets just slamming into it, could have vaporized a lot of dust or blasted it right off. Okay, big impacts cleared out some dust, but wouldn't it have kept building up over the billions of years after that exactly? That's one of the main issues with that theory. Even if you account for those early impacts, you still got a ton of time, at least a billion years, where dust should have been piling up at that rate the DDE measured. And that brings us back to square one. Where'd all that dust go? So we've got this lunar dust mystery. It's like a case, but the evidence is a mountain of dust that's vanished. What I find even more intriguing is how this dust problem ties into something way bigger, the age of the whole solar system. Right, you're spot on there. This missing lunar dust, it's not just some weird thing by itself, it's part of this bigger discussion about planets cooling down and the energy we see all over our cosmic neighborhood. Planetary cooling. Okay, now you've got to explain that one. How does dust on the moon connect to how hot or cold planets are? Well, imagine you have, say, a really hot cup of coffee. What happens? It cools down, obviously. Unless you're one of those people who likes their coffee lukewarm. But I digress. What's the point? The point is heat. It goes away over time, right? It's like a basic law of physics, thermodynamics. Now think about planets and moons. If our solar system really is billions of years old, everything should have cooled down a lot by now. But that's not what we see. There's tons of heat and geological activity all over the place, not just on Earth. Okay, I'm following you. Give me some examples. What kind of activity are we talking about? We'll start with us right here on Earth. Our planet, it still has this molten outer core, a dynamic mantle, volcanoes erupting everywhere. All signs of a planet that's definitely not some cold, dead rock. True, Earth is pretty lively, but I remember reading about other planets and moons being even more dramatic. Oh, absolutely, like Io, one of Jupiter's moons, most volcanic place in the solar system, spewing lava like crazy. Hard to believe it could be doing that for billions of years. And then, there's Neptune way out there, freezing cold, but it gives off more than double the energy it gets from the sun. Wow, yeah, a lot of extra heat for a planet that should have cooled down ages ago. So we have these celestial objects acting younger than they should be, like finding a senior citizen running marathons and bench pressing cars. Huh, love that analogy. And it's not just those two. Enceladus, Saturn's moon, has these geysers shooting water vapor into space. Means there's internal heat and activity going on. Even Pluto, used to think it was just a frozen ball of nothing, shows signs of recent geological stuff happening. All of this really challenges the idea that our solar system is super old. This is blowing my mind a little bit. Are you saying the solar system, the moon, all of it could be much younger than we thought, like thousands of years? It's definitely a bold idea. And not everyone agrees with it, of course. Scientists have these pretty established ways of dating things in space, like radiometric dating, and that points to a very old solar system. But the data we've been talking about, from the moon dust to how planets are cooling, it raises some pretty interesting questions about how old we think our little corner of the universe is. You said not everyone agrees. I bet challenging something as big as the age of the solar system doesn't make you too many friends in certain circles. Yeah, you're not wrong. This idea goes against the mainstream, the accepted view, and there's definitely some pushback against changing that timeline. But we have to remember, science is all about questioning, testing, refining our understanding. The dust data and seeing how planets are cooling, it makes us rethink those assumptions and maybe consider some alternative explanations. That reminds me of Brian O'Brien, the physicist who made that DDE. I read somewhere he's been pretty vocal about his findings. Oh yeah, definitely. O'Brien thinks NASA hasn't really given his work the attention it deserves, downplaying the significance of the dust data. Thinks it should be talked about more openly in the scientific community. And let's not forget Bob Ackgill. We've got his opinion piece here. Seems pretty passionate about this dust thing. Ackgill is a big supporter of O'Brien's work. He says the DDE data has been dismissed or ignored unfairly. Thinks it has huge implications for understanding not just the moon's history, but maybe even the origins of Earth and the universe. So he sees this lunar dust as a piece of a much bigger puzzle. Exactly. For Ackgill, this seemingly small thing, the missing dust, could change how we see the cosmos. Okay, so we've got these two camps, right? Those who stick with the old solar system, and those who propose a much younger one based on the dust and other things. It's a cool debate for sure. But before we go any further, let's get back to those standard explanations for the missing dust. We talked about micrometeorites and those early impacts, but weren't there other theories too? Yeah, there are a couple more worth looking at. One's about electrostatic levitation, the other focuses on volcanoes. But the big question is, do they really hold up under scrutiny? Alright, let's tackle those other explanations you mentioned. Electrostatic levitation. Is the moon like losing its dust to space, like a cosmic vacuum cleaner? Haha, it's an interesting thought. The idea is that electric charges, maybe from the sun's radiation or solar wind, could lift dust particles off the surface and just fling them into space. Oh, canned. But NASA's done some recent research and it doesn't really support that theory. Turns out there isn't much high-altitude lunar dust hanging around in orbit, so no lunar dust halo. What about volcanoes? Could ancient volcanoes have something to do with this missing dust? Some scientists think maybe lava flows from back when the moon was more volcanically active. Maybe they covered up some of the dust that was already there, like paving a dirt road. The dust is still there just underneath. So you could be looking in the wrong place, buried under old lava. It's possible some dust got trapped under lava, sure, but that wouldn't explain why there's no dust from the last billion years. Even if volcanoes were resurfacing the moon a billion years ago, we'd still expect to see a decent layer of dust on top of those flows, and we just don't. So we've gone through micrometeorites, early bombardments, electrostatic stuff, even volcanoes. Nothing really explains it completely. Seems like we're left with this big question mark hanging over the moon. Exactly. The dust discrepancy really challenges how we think about the moon's history. And like we said before, maybe even the age of the whole solar system. It's bigger than just finding some dust. It's about stepping back and asking, are we sure about what we think we know? Are there other possibilities? It's like we found this loose thread, and the more we pull on it, the more we realize it's connected to everything. So, what does this mean for the average person, someone who's not a scientist but trying to wrap their head around all this? It shows us that science is always changing. We're always learning new things that challenge what we thought was true. This dust mystery, it forces us to ask why. What do we really know? And maybe the more important question is, what don't we know yet? I always like thinking that science has all the answers, but it's kind of cooler to realize there are still so many mysteries out there. What do you think, listener? Does this lunar dust thing make you question what you thought you knew about the moon, the solar system, maybe even the whole universe? It reminds me that science is about being curious, exploring, always searching for new knowledge. Who knows? Maybe one of our listeners will get inspired, dive into this dust mystery, and make some incredible discovery that changes how we see the cosmos. Now that's something to think about, and if you want to learn more, we definitely encourage you to check out the work of Brian O'Brien, the guy behind the Apollo dust detector experiment. Dig into this whole debate about how old the moon and the solar system really are. And most importantly, never stop questioning, exploring, and just looking up at the stars with a sense of wonder. This is The Deep Dive, signing off. We might be leaving you with more questions than answers, but hopefully you're feeling a little more awe for all the mysteries the universe holds.